Well, good morning, all. I am Andy Hayner. I am a lead meteorologist at the National Weather Service in Tallahassee, and it is great to be with you. I took over in October as the fire weather program leader at Tallahassee after the retirement of Tim Berry, who is actually here today. So it's great to see Tim. It's good to see there's life after retirement. In fact, it sounds like there's maybe even more life after retirement than before. So good to see you, Tim. So anyway, I've got a couple of things that I'm going to talk to you about today. And the first thing is I'm going to talk about, the past weather over the last couple of months, how it leads into where we are right now in terms of, drought and dryness and that kind of thing. And then I'll launch into an outlook looking out as far as about the next 2 to 3 months in terms of what we're expecting for weather and climate conditions. I'm also going to do a quick review of a couple of forecast parameters and sources for getting weather information. And then I'm going to, if I've got time at the end, I'm going to talk about thunderstorm wind shifts, which is kind of my pet peeve when it comes to firefighter safety. So we'll see if we've got time for that. Okay, so first of all, looking at fire season, it's kind of interesting. About a decade or so ago, there was a survey of fire managers that was done that basically asked, what do you consider to be a bad fire weather day? And probably not surprisingly, fairly intuitively, the answer was a day that's hot, dry, and windy. So some researchers came up with this index to define hot, dry, and windy. It's an elegantly simple equation that gets you this. But anyway, this is the climatology of hot, dry, windy conditions for especially Northwest Florida. The point that I centered this at is actually out near somewhere between Mariana and Defuniak Springs. So basically like the Eastern Panhandle. And you can see that there's a peak in hot, dry, windy conditions over Northwest and North Florida during the months of May and into early June. And not coincidentally, that is the peak of North Florida fire season. There is this secondary peak in especially late September, after we've started to dry out the atmosphere heading into fall. And sometimes that time of year, we can also end up on the outskirts of tropical systems that kick up the wind and bring drier conditions. Looking further south down the peninsula, I've got a point here centered on Sebring, and the season down there is definitely more of a spike earlier in May. Of course, the rainy season here typically begins in mid-June. The summer thunderstorm season down there, it begins about a whole month sooner in the middle of May. So it basically peaks just before the start of the summer rainy season. So next, I'm going to review I'm going to review January, February, and March in terms of rainfall. And what you're seeing up here, these shades of colors, represent the percent of normal rainfall that occurred in the month of January. And so first I've got, the whole state of Florida, and then the next slide, I'm going to focus in on Florida. So if you find yourself squinting on the place that you care the most about, the next slide will help you unsquint. So anyway, in the month of January, most of Florida was actually drier than normal. There were a few spots that actually had near or even above normal rainfall, especially down along the southeast coast of Florida. There was a pretty good swath of rain in the middle of January that extended from, Bay County and Panama City, actually across Calhoun, Liberty, and Wakulla counties. But otherwise, most of the state was drier than normal. And especially if you look down, like between about Live Oak and Lake City down toward the Orlando area, some places didn't even get 25% of their normal rainfall. In fact, here's that slightly zoomed in view of North Florida. This was January. So we'll move on to February. What happened in February? February was just a classic La Nina month, with La Nina conditions, which we'll talk more about in a little bit. The southern tier of the US, including Florida, tends to get a drier than normal winter, and February just fit the bill perfectly. Most of Florida, in fact, had less than half the normal amount of rain for the month of February. There were places, especially down along the Nature Coast, even down around Apalachicola, that had less than 25% of normal. And those very places that I pointed out, like from Panama City, across toward Tallahassee, south of Tallahassee, Wakulla County, that had that actually got some rain in January. They failed to get any rain in February. And, not coincidentally, at the end of February, that's when we started to see an uptick in wildfire activity. Of course, the biggest of them all was the Bertha Swamp Road wildfire that got going out near the where Gulf Calhoun and Bay counties all meet, and turned into a 33,000 acre fire out there in Hurricane Michael timber country, hurricane timber. So finally, March, man, things really, it's like a switch flipped as we got to the beginning of March. Many of the same places that were suffering from months of lack of rainfall, they really picked up the rainfall in March. Basically from, about Chattahoochee, Bay County on down past Tallahassee, and especially, the Nature Coast, down past Cross City, Crystal River, across to Orlando, up to Jacksonville. They really made up for the lack of rainfall in January. But looking down the peninsula, it's interesting to see how stark that line is, where the rainfall just basically cut off, from Tampa over to south of Lakeland and over toward Melbourne. Once you got south of there, down around the Fort Myers area, Fort Myers and Naples, less than 25% of the normal rainfall. So our abundance up here didn't mean any kind of abundance down the southern half of the peninsula. But looking out toward the Panhandle, there were definitely spots that missed out on the heaviest rainfall. In fact, January, February, especially the coastal Panhandle out toward Escambia and Santa Rosa counties were at quite a deficit. And March wasn't really enough. It was maybe enough to keep things from getting worse out there, but it really wasn't enough to make up for that deficit. Okay, so looking now at the Keach-Byram Drought Index, as you really kind of zoom in on the southeast in Florida, again, there's that sharp, stark line. That is quite the gradient in, moist conditions to the north and dry conditions to the south, extending from Tampa Bay on to the east. So things around here are fairly moist at this point. So one thing to look at is the evaporative drought demand, or the evaporative drought index. And this just basically, I would qualitatively say it's a decent measure of the thirst of the atmosphere. How thirsty is the atmosphere, for evaporating moisture out of the fuels. And so most of the state of Florida, the evaporative drought demand has been above normal over the last month. We haven't, yeah.
Minimize this so they can see.
Oh, okay.
It's blocking their view. I'm sorry.
No worries.
There.
Awesome. Thank you. Yeah, so it's been high, and especially high over the southern half of the peninsula where they've had fewer cloudy, rainy days. Let's see. There we go. Okay, so how does this all boil down? Is one of the things that we're going to look at here is the latest rendition of the drought monitor. This is using data that was valid on March 29th. Okay, so almost a week ago now. In fact, yeah, a week ago today. And it's interesting. I show the whole US at first because I can barely remember a time where so much of the US was in drought, in a state of drought. You really kind of have to point out the areas that are not in drought right now. But zooming in on, let's see, yeah, zooming in on the southeast, and then I'll zoom in on Florida. But there's still, I pointed out the Western Panhandle really didn't make up for their dryness in March. And so we still have, the drought monitor still points to abnormally dry conditions out over the Panhandle, basically, Panama City up to Mariana and points west. Of course, where we had plenty of rain in March, there's now it's not abnormally dry. There's no drought conditions, but as you get south of the Nature Coast down toward the Tampa Bay area, especially down around the Fort Myers and Naples area, that's where things are basically bad and getting worse. So down there, it's considered moderate drought. Now, the data cutoff for this was a week ago today. So what's happened in the last week? Oh yeah, here's the zoomed in view of Florida. Okay, so what's happened in the last week? since March 29th. And many of those same places, especially north of the Tampa Bay area, up through Pasco, Hernando, Citrus counties that were in moderate drought a week ago, they have just been pummeled with rain over the last week. You can see in this map that they've had 5, 6 to 8 inches of rain in places down there. And even up here in North Florida, especially once you get west of about Madison, most places have picked up 1 to 3 inches of rain. So not bad, but those same parts of the state that are the driest down around Fort Myers and Naples, they've gotten basically no relief. This 1/10 to 1/4 of an inch, that is not relief when you're already that dry. So zooming into North Florida, one area that I want to point out is once you get east of about Madison, with the latest rain system that came through this past week, the Jacksonville hole was in full effect. You can see, especially, from Live Oak on north to the state line and east across, basically parts of the Osceola National Forest, the Okefenokee, that area got little, if any, rain. And that's one of the areas right now where fire danger is higher. So now looking out for the next 7 days, what's going to happen now over the next 7 days? And much of North Florida is going to get some heavy rain. Tomorrow is actually a little concerning for some in terms of how much rain we could get. So on this scale, I mean, there's a forecast here of some places getting 5 to 7 inches of rain along the I-10 corridor from Tallahassee on east to almost to Jacksonville. Move down the peninsula and not much relief is forecast. So now we're going to move on beyond the next week. Weather forecasting goes out 7 days. Climate forecasting is basically 8 days on out. And so we're going to look at these climate outlooks for 8 to 14 days in the future. And what you see is the entire state is expecting above normal temperatures. Once you get from here on southeast down the peninsula, near normal precipitation, from here on west, the odds lean toward above normal precipitation. In fact, this pattern that you see with cooler than normal temperatures over the western US and warmer than normal temperatures over the eastern is also here in the spring favorable for severe weather. And so that threat is centered, right where you see that bullseye of above normal odds for above normal precipitation, especially over the lower Mississippi Valley and perhaps even the Western Panhandle. I could see them getting in on the act in that 1 to 2 week time frame. So basically, it looks like more relief for North and especially Northwest Florida. Of course, as we get into mid-April, the peninsula typically doesn't get that much rain anyway, so a forecast of near normal rainfall is not really that much relief this time of year. Looking out 3 to 4 weeks into the future, basically the second half of April, and this is where the climate forecasters start to hang their hat a little more on La Nina, which classically comes with below normal rainfall over the southern tier of the US. And you see, that's definitely the case from Texas on west across the Southwest. And they have odds slightly favoring below normal rainfall down over the peninsula and near normal up here in North Florida. Okay, so I talked about La Nina, and that's basically, La Nina is basically I don't know which one is the evil twin, but basically La Nina and El Nino are kind of like, you've got the good twin and the evil twin, And so with El Nino, you get basically this large swath of the tropical East Pacific, where the sea surface temperatures are, a couple of degrees warmer than normal. And with La Nina, it's basically the opposite. You get this large swath of the eastern tropical Pacific where the water temperatures are cooler than normal. And that's where we're at right now. And, some may ask, why is a couple of degrees of temperature out in the eastern Pacific so important? And when you consider how much energy it takes to boil a pot of water on your stove, you're sitting there, even if you've got a gas stove, you're still sitting there for a couple minutes waiting for it to boil as all this energy is released onto your pot of water. Well, just magnify that by many orders of magnitude, and you've got this vast swath of ocean water. And imagine the amount of energy that it takes to heat that up a few degrees. Imagine the amount of energy that is released from all that water, by increasing the water temperature by just a few degrees. And, just that release of energy, or in the case of La Nina, the lack thereof, it affects weather patterns all around the globe. And so here in North America, typically with La Nina, you end up with warmer and drier conditions across the southern tier of the US. And the northern US typically gets wetter and cooler winters than normal. For the northern US, these end up being the snowy winters. So yeah, that's part of what I've been trying to explain there. But anyway, La Nina, right now the climate forecasters are pointing to a 53% chance of La Nina conditions continuing into summer, basically the months of June, July, and August. And after that time, the climate forecasts show La Nina basically dissipating and going to more of a neutral state. On this graph, where you see all the lines that are below the black line, that's basically more of a La Nina condition. Once it gets up close to the black line, that's basically a forecast of more neutral type conditions. So yeah, once again, as you get out late summer into the fall, conditions are expected to drift more toward neutral. Now, compared to when I was first, breaking out these La Nina forecasts back in January, the forecast back then was for La Nina to basically dissipate by summer. So now La Nina is lingering a little longer than was being forecast a couple months ago. So that is, that's one difference. If you saw some of these forecasts a couple months ago, that's probably the biggest difference that you're seeing in the forecast now. So, moving out to these climate outlooks, here we're looking at the months of April, May, and June combined. So basically, the peak of fire season in Florida, and the forecast is calling for above normal temperatures, classic La Nina. But the forecast for Florida is calling for near normal precipitation. I think that for Florida, especially in May, which is typically about the driest month of the year for Florida as a whole, near normal precipitation basically is a dry forecast. What I do see in this too, though, is an expectation that the summer rainy season is expected to basically begin on time. So down the peninsula, we're talking the middle of May. Here in North Florida, we're talking the middle of June. So that's so that relief, that relief that comes with the summer rainy season should arrive on time this year. So here's the drought outlook moving all the way out through June. And basically for any part of Florida right now that's currently in drought, it's not expected to be in drought by the end of June. I don't see much relief down the peninsula, especially Southwest Florida, until the rainy season kicks in. But once the rainy season kicks in, drought is over. But unfortunately, for so much of the US that's currently in drought conditions, little, if any, relief is expected through the end of June. So that's unfortunate. Okay, so now looking at the month-by-month significant fire potential outlooks. These are issued by the predictive service units at the 10 different geographic area coordination centers around the nation. And for the month of April, there's a forecast of above normal significant wildfire potential down the peninsula, near normal here in North Florida. Once again, if you saw these outlooks a couple months ago, the forecast was above normal for the entire state of Florida. So all this recent rain and the rain to come has really kind of, no pun intended, damp down the expectation for North Florida. Moving out through May for Florida, there's basically no change. And then June, we revert back to near normal conditions for the entire state of Florida. And again, that's also reflects the expectation that the summer rainy season is going to begin on time this year. So in summary for the outlook, again, this is just the first phase of the time I've got with you, but for North Florida, we're at this point expecting near normal fire potential through the spring, which, as you saw in that very first slide, looking at North Florida climatology, using that hot, dry, windy index, fire season around here typically peaks in May and early June. So we're still expecting, a rise toward that peak of wildfire season as we move into May and early June. But at this point, for North Florida, we're not expecting anything much worse than normal. Down the peninsula, that could be different. Okay, so we're going to shift gears now, and we're going to talk a little bit about a couple of forecast parameters that you may see in the fire weather forecast. I'm also going to talk a little bit briefly, at least, about some sources of getting fire weather information. So about a year ago, I took a call from a fire manager, and the question was, why is the dispersion index in my spot forecast so much less than in the fire weather planning forecast? Obviously, for prescribed burners, that can make or break your day in terms of shutting down your burn for the day. So I'm going to set out to answer that question for you. And the first thing I'm going to show, this is from about the middle of February, I believe. But anyway, this shows, first of all, sea surface temperatures across the Gulf of Mexico and out into the Bahamas. And, one of the first things that stands out to you is that warm tongue of water off the east coast of Florida. That's the Gulf Stream. But up here in the Northeast Gulf, at the time I took this screenshot about a month ago, water temperatures were in the mid 60s. And so, basically on a day where your temperatures on land, or at least inland, are like well up into the 80s, and you get this sea breeze kick in off these cool, 65 to 70 degree waters, getting that cool air moving in down low with your afternoon sea breeze, it really lowers your mixing height, and it lowers the dispersion index forecast, right near the coast. So let's see, I took this screenshot from a webcam down at St. Teresa, that's on the coast of Franklin County, back on a day in mid-December when the camera spotted some sea fog offshore. And I picked this picture just because it so nicely visualizes, that the effect of the marine layer. When the sea breeze kicks in at the coast, it's basically bringing in this cooler, more stable air that is offshore over the cooler waters onto shore. And so, hopefully this is just a good visualization. Obviously, even on days when you don't have fog offshore, which is most days of the year, let's face it, you still, though, have that, especially in the spring when the waters are cooler, you still have that shallow, cool layer of air off the coast that moves onshore with the afternoon sea breeze. So, so this is actually a screenshot from our own forecast database, from back in February, showing the forecast dispersion index, for an afternoon in February that our forecasters were massaging and manipulating, basically. But anyway, what you see here are these significantly lower dispersion index values down along the coast. For example, down at St. Mark's on this particular day, dispersion index values of 17 to 21, which obviously that's pretty low. I know that's definitely lower than the desirable range for ideal prescribed burning. But meanwhile, you move inland to Tallahassee, dispersion index this day was 40, and out over the inland panhandle, it was at a pretty nice, 50 to 60 range for burning. So this is just to point out that going back to that original question, why is the dispersion index in my spot forecast so much different or so much less than in the fire weather planning forecast? Well, the spot forecast that burners typically request, is specifically for your spot. So if you are forecasting, or if you're requesting a spot for, for Shell Point, for example, where the dispersion index is 17, in contrast, the fire weather planning forecast, that basically is an average, more or less, of conditions across a fire weather zone. In this case, the fire weather zone extends well inland into Wakulla County, south of Tallahassee. And so when you average out the higher dispersion index values further inland with the lower dispersion index values at the coast, well, you start to get the idea of why there can sometimes, especially near the coast, be such a difference between those two values. So I've been throwing around a couple of terms here. I've been talking about the fire weather planning forecast, the spot forecast, without really giving much of an introduction to those things. So maybe this is putting the cart before the horse. I've kind of given you the punchline already, but anyway, one source of fire weather forecast information is our fire weather planning forecast. I have FWF there because many times in our office we just refer to it as the FWF, but it basically represents average conditions over a zone. And a typical fire weather zone is about the size of a county. So again, we're averaging conditions out over a fairly substantial area. The fire weather forecast represents conditions over a set time period, typically 6 a.m. to 6 p.m. and 6 p.m. to 6 a.m. In contrast, when you get a spot forecast for your specific burn, we're going to provide an hour-by-hour forecast of conditions. I will say, it says average conditions, and like for mixing height, for example, it does at least pick out the highest mixing height of the day to put into the fire weather planning forecast, the highest average of the day, So again, it isn't necessarily going to do a very good job of reflecting localized weather detail. This is not the forecast that's going to tell you what time the sea breeze arrives at your location. It will give you kind of a big, broad, general picture of what's going on. I actually took this screenshot conveniently yesterday. Procrastinator, I suppose, but you can see that, for example, if you can squint good enough, yesterday, there wasn't much wind yesterday, and the forecast in the fire weather planning forecast was south at 4. Today, the forecast issued yesterday morning showed a south wind of 10 gusting 21 miles an hour. This is my main point here is that this is more a reflection. When you walk outside today, you're going to notice it's definitely windier, or at least a little more of a breeze than there was yesterday. And so it's kind of those generalities that the fire weather planning forecast is going to get you. In contrast, the National Weather Service spot forecast, and I know Brian, he does spot forecasts as well for Florida's Forest Service. And so the spot forecast, it includes a site-specific discussion. And in fact, I think that may be the most valuable part of the spot forecast, because many of the forecast values you can actually go on the internet and get, and I'll show you how to do that as well. But the discussion, that's our forecasters, our meteorologists by training and trade, basically hopefully providing some extra value to just the numbers that you're going to see in the table that comes out with the spot forecast. But there is an hour-by-hour forecast, and I've been providing some training for our staff this spring. And one of the things that I've been emphasizing is using that discussion to add value to the numbers. And if they don't like the numbers, basically they need to redo the forecast. So just 2 tips for when you're submitting a spot forecast request. First of all, spot forecast requests to the National Weather Service, they're intended for our intergovernmental partners, such as basically our federal, state, local partners. We'll also do spot forecasts for any contract agent who is working for the state or working for the federal government, or even a local fire department that's doing a prescribed burn. So I want to encourage you, when you're submitting a spot forecast request at weather.gov/spot, that's the webpage, weather.gov/spot, weather.gov/spot. All right, is to use the remarks, because our forecasters, they see, before they ever do the forecast, they see your remarks, the remarks that you submit with your spot forecast. So for example, if your burn operation is particularly sensitive to, the difference between, I'll just hypothetically say a 30 and 40% RH, our forecasters will be paying more attention and focusing that discussion more on the specifics of, of a 30 versus 40% RH. What's probably more likely is you're concerned about the wind direction on a given day. Maybe for the either your burn accomplishing its objective or trying to keep smoke off of a certain highway. And so in the remarks, let's say your burn is particularly sensitive to a south wind. Say that in the remarks. Say, my burn is particularly sensitive to a south wind. I want to hear more about the possibility of a south wind. Our forecasters are going to see that remark, and when they so when they go to do the spot forecast, it's not going to change the values in the forecast, but I can almost guarantee you that they will, that a large part of the focus of that handwritten discussion at the top will be on the possibility of you getting a south wind. And so they will add value in that way. One other thing you can get with a spot forecast request is a Hysplit plume trajectory. Hysplit is it's a model that was developed quite a few years ago by the Weather Service. As it says, it's a plume trajectory model. It was originally developed. Hysplit is not the model you want to use if you have, for example, a chemical release. You've got Cameo and Aloha, those really kind of neighborhood scale type models, that can account for, a chemical's density and its dispersiveness and all of those, kind of qualities that chemicals take on. But Hysplit is great for showing you kind of in general terms where smoke is going to go. Is smoke that's generated over Wakulla County today going to come up over Tallahassee, for example? So it can help you answer the question, where will the smoke go? So when you submit a spot forecast request, there's that little box there that asks if you want a Hysplit model run or not, and you can click yes or no. And so if you click yes, within about 5 minutes, you as the requester are going to be automatically emailed the Hysplit results in 3 formats. One is just a tabular format, which quite frankly is kind of ugly on the eyes. But then there's you get a GIF image and you will get a KML file that you can insert into Google Earth. And so I'll show you I'm not going to show you the tabular output, but I'm going to show you examples of the GIF image and the KML output. So this is an example of a GIF image from a burn down at a couple of years ago at Key Deer National Wildlife Refuge in the Florida Keys. And there's 3 lines on there. So the green line, I'll start with the red line. The red line is the most important one. That basically means that any smoke that lofts to 500 meters above the ground, it shows you where that smoke that's 500 meters off the ground is going to go. The blue line, if you get smoke that lofts to 1,500 meters above the ground, it shows you where that smoke is going to go. And in the unlikely event that you get smoke that lofts all the way to 3,000 meters, so that's like about 9,000 or 10,000 feet, it shows you where that smoke will go. Typically, smoke is not lofting up that high, but it is typically lofting up into that red level, that 500 meter level. So that is the most important line. And here's an example of KML output. I actually did this example probably about 15 years ago. So I'm sure Google Earth looks a little better than this now, but you can get with Google Earth, you get these great 3D visualizations of basically the smoke trajectory. So, in this example, you see how the smoke down low is going to head off, more to the right, and the smoke way up high is going to head off more, we're facing east in this image. So basically, the smoke down low is going to head off to the south, the smoke up high is going to head off to the east. It's that smoke down low that you really are most concerned about. Okay, so I'm going to show you a couple of forecast resources. How can you I mentioned that you can go on the internet and get those forecast values. Basically the same forecast values that you would get in a spot forecast, just without the discussion and without that human interaction. If you just want to go into our database and get the forecast values, there's this great tool called the Fire Weather Dashboard. And I've got this shortened URL up here. I'm going to show this URL again 2 slides from now. So basically, if I sell you on it here in the next slide, you'll have one more chance to write it down. But the fire weather dashboard, if you go to that URL that I showed, and this is available nationwide or for the entire state of Florida. This particular URL will zoom you in close to the Tallahassee area, and it has just a great, like, color-coded, easy on the eyes. For being a tabular readout, it's really easy on the eyes, especially with the color coding. In this example, you can look out for the next 7 or 8 days and get an idea of how temperatures and humidity will be trending over the next week. And same with winds and mixing heights, at least for the next 3 to 4 days. If you've got a burn going on today and you really want that hour by hour breakdown, the fire weather dashboard can give you that hour by hour breakdown. So, in the top lines, you see temperature and humidity, but you also see that hour by hour breakdown of wind as well, and sky cover. Here's, if you really like graphs, the wavy lines, it has the capability to give you graphs of temperature moving all the way out, temperature and all kinds of other weather parameters moving out for the next week. And this is just an example of other types of the graphical displays. So, for example, in the second line down, this is a graph showing trends in transport wind over the next like 3 days. So you can see on day 1, transport winds were coming out of the north, but then days 2 and 3, it's going to be coming out of the east. So you can certainly use this to help plan things moving out a couple days. So again, there's that URL address. I'll leave it up here for about 20 seconds while you write it down. And I see I've got just a few minutes left, so I definitely don't want to run over. So I'm just going to show you, I'm going to move on. Oh, that's right, I wanted to talk about superfog. Obviously, superfog is a big deal. We saw again vividly this year over on I-95 south of the Jacksonville area. We had another one of these superfog pileups that killed 3 people and closed down a major interstate highway for 24 hours. So there have been a couple of other major pileups around Florida over the years. In 2008, there was a pileup, 70-car pileup on Interstate 4. In 2012, there was the pileup on I-75 at Paynes Prairie. And so the pileup back in 2008 on Interstate 4 inspired the National Weather Service to start including this index, the Low Visibility Occurrence Risk Index, in our forecasts. And basically, this is really geared toward forecasting those conditions that could lead to unsafe conditions on highways. The kind of conditions that on a high-speed highway could lead to pileups. So superfog, of course, the condition itself is, fog, of course, is fairly common, but then you add in, the damp smoldering material, throwing in smoke into this really humid, stable atmosphere, and it's a ripe setup for superfog. Under superfog conditions, you can easily get visibility that's 10 feet or less. So this is just one more example, or one more aerial picture of that Interstate 4 pileup after the fog started to clear from the Orlando Sentinel. So the Lavori, as we call it, the French pronunciation, it goes on a scale of 1 to 10. And once you get to a 7 or higher, you're basically at a high risk for getting superfog, especially with the contribution of fire. And many times, by the time you get up to a 9 or 10, you'll see that the Weather Service actually has fog explicitly in the forecast. You can still get superfog pretty easily with a Lavori of 7 or 8, especially with the contribution of smoke from damp smoldering material. But the conditions that will get you a high Lavori value are low dispersion and high relative humidity. And so if you have those two values, if you have low dispersion and high relative humidity, you're going to get a high Lavori value. So I will say it's kind of interesting because back in early March, when we had those when we had all the wildfires around. Actually, there was a prescribed burn out near Lake Talquin, out west of Tallahassee. And it was actually on a very dry day. In fact, the Livory that night was a 5. So that's only a moderate risk. But we ended up with State Highway 20 west of Tallahassee, about 20 or 30 miles out, closed down between, I was on the midnight shift. And so that highway was closed down between about midnight and 5 a.m. on a night when the Livory was only a 5. And, you know, it kind of left me scratching my head. It's like, you know, how did this get so thick on a night when the Livory was a 5 that the FHP reported visibility of 2 feet. I mean, that's like only that far. And 2 feet and closed down a highway, a state highway for 5 hours. And all I could speculate, it had been a really dry day. And even the evening, the relative humidity did not drop as quickly as usual in the evening. So all I could speculate was that was because of the dry conditions, perhaps the fire continued to burn more actively to, you know, later into the night. This was a prescribed burn. And so maybe just the extra smoke generation caused, you know, contributed to this particular highway closure. So Livory is it's not a magic bullet in and of itself. You know, certainly if you've got a fire that's going to burn actively late into the night, then I could see, you know, these kinds of super fog conditions as well. So at this point, I'm going to respect my time limit and go ahead and cut it clean here. So do we have time for a couple of questions? Okay. Yes, sir.
Working towards growing season burns, especially a little bit further south, we get into thunderstorm conditions. Do you have any suggestions to where you can find good burning conditions and ways we can avoid the thunderstorm activity?
Well, it's kind of interesting. What I was about to launch into is one of these recommendations from the St. Sebastian burnover from the prescribed fire down in Indian River County back in 2004. This recommendation that each prescribed fire have a dedicated weather observer position. And so what I was going to show you were what to look for on radar, you know, what a thunderstorm outflow boundary looks like. And, you know, when folks these days compared to 2004 now have a radar in their pocket, you know, that goes with them everywhere. And, you know, the bright oranges and reds are pretty obvious, but when you get these fine lines that move out from the storms, you know, that kind of emanate out from the storms, those can be really dangerous to wildfires and prescribed burn operations. You know, when it causes that sudden, fast, just whipping, like 90 to 180 degree whip around of the wind. So you were asking about thunderstorms. And so for real-time monitoring, you know, you want to be looking for these outflow boundaries. But if you're talking about planning, my recommendation would be to call the National Weather Service. In fact, one of the things I wanted to show you here is the phone number for every Weather Service office covering the state of Florida. We're happy to talk to you. We're happy to do a deeper dive on thunderstorm potential moving out for a couple days, how things might progress. You know, things definitely progress differently on a summer day with southeast flow versus southwest flow, and, you know, areas that are favored for thunderstorms under those types of conditions. So I'll leave that up there. Also, actually, I'll go to my email address real quick and then just leave it on this slide. I'm Andy Hayner. I work for the National Weather Service, and my email address, if you also have any follow-up questions that we can't get to today, it's andrew.hayner@noaa.gov. andrew.hayner@noaa.gov. So yeah, thunderstorms, it's complicated, and obviously we've seen examples all over the place where they can be dangerous. If I had another 20 minutes, I would have probably shown about 4 or 5 different examples. So Yeah, and actually it's kind of interesting if you read the learning report from the St. Sebastian burnover, which has now been 18 years, hard to believe, but it mentioned that they first noticed sky, this was February, so this was winter, that they saw skies growing dark off to the northwest. And they actually increased the pace of ignition because they wanted to get some more burning done before the mop-up crew arrived, in the form of a thunderstorm. And I really kind of chewed on that for a while. Us folks from Florida, we see far more thunderstorms in the summer. So that's kind of what we get conditioned to. And, I grew up in Florida myself, and in the summer, the sky can grow dark off in the distance. You can even start to hear thunder, but it could take an hour or 2 or even 3 to actually get a thunderstorm to your location. But in the winter, like February, when St. Sebastian burn was taking place, storms move much faster in the winter. So, if it's wintertime, pretty much as soon as you see skies grow dark off in the distance, it's going to come on you much faster than our summertime conditioning has gotten us used to. So just be aware of that distinct difference between winter thunderstorms and summer thunderstorms. Yeah. Okay. Well, thanks for your time, and I'll be around probably till about 11 before I've got to get to the office. Thanks.